for mixed numbers and improper fractions. We're going to learn how to convert between a mixed number and improper fraction, between those two, and we're going to talk a little bit about what an improper fraction is all about. Here are some of the key terms that you need to know. Pause the video, write down the term, the definition, and any notations that go along with it. Okay, now one of the first things we're going to talk about is why is a fraction considered improper? What makes it improper? First things we're going to get into before we get into converting mixed numbers and improper fractions is answering this question, which is why is it called an improper fraction? Where does it get that name? A lot of people confuse the fact that it's called improper because it doesn't look like a proper fraction, which is somewhat true. Some people just say, oh, 19/7. It's big on top and small on the bottom. I've heard some people describe it as an upside-down snowman. It's too big on top, too small on the bottom. It's not going to stand. That's one way to put it. First, talk about this part of the number line. Now, that part of the number line is where all the regular fractions go. Okay, a lot of the regular fractions fit in this part right here. So, for instance, that's where 1/2 is. This is where 1/4 is, 1/4. This is where 1/3 is. Right here is, maybe you can call that 9. I'm just making stuff up right now, but 9/11 or whatever. But that's where all regular fractions go. Here's where 1/10 goes. So all regular fractions where the numerator is smaller than the denominator fit in this little region right here. That's where all fractions fit, between 0 and 1. That's what a regular fraction is. We just don't call it a regular fraction. We don't call it a proper fraction either. We just call it a fraction. All fractions are there. Now the reason it's called improper, not in this area, it's not in this region between 0 and 1. So improper fractions, if you have something like 3/2, something really simple, 3/2. Well, 3/2 means 3/2. It means 3/2. So a half looks like this. Okay? So there's 1/2. That's 1/2. And then I'm going to go another half. There's 2/2. And then there's 3/2. So that's what 3/2 means. It means 1.5 basically. Sorry about my handwriting there, but yeah, it's 1.5. Okay, that's why it's called improper. Now, 7/3, if we break this down, well, 1/3 of the whole looks like that. This is what 1/3 looks like. Right there, that's 1/3. And there's another. So we're looking at all the thirds. Third. Here's another third. That's 2/3. So we're still in the 0 to 1 range. And there you go, 3/3. 3/3 is 1 whole. 4/4 is 1 whole. 5/5 is 1 whole. Okay, there's 4/3. So now we're in improper territory. Right here, 5/3. Right here, 6/3. Now 6/3 equals 2. And that's where we're at right now. And then right here would be 7/3. So there's a little bit of a description of what an improper fraction is all about. It doesn't fit in that region between 0 and 1. That's essentially what we're talking about. Okay, now let's get into how to change all this. Now we'll start with the easiest thing to do, which is changing it from a mixed number to an improper fraction. The steps are, first, multiply the denominator by the whole number. We start at the bottom and we multiply those numbers. 5 times 4 is 20. Then our next step is add the product. Now product means the answer to a multiplication problem. That's the product, 20, to the numerator, which is 2. So now we're going to add it to 2, and now you get 22. Then the number you get in step 2 is your new numerator, and the denominator stays the same. So our answer is 22 fifths. And there you have it, 22 fifths. That's what 4 2/5 looks like as an improper fraction. Let's go through some others here. So let's do this one. 2 times 7 is 14. 14 plus 1 is 15. And then what stays the same? The denominator. So you get 5 halves. And so you get 15 halves. Okay, let's start with 8 times 15. Now 8 times 15 is 120. Okay? Then you do 120 plus 3. 120 plus 3 is not difficult. 123 over 8. So that's 123 eighths. Moving right along. Let's do this one. 10 times 6 is 60. 60 plus 2 is 62. So the arithmetic is not too tough. Now in this instance right here, in this example, you will want to reduce. Now that's going to be one of the things that you want to look for when you guys are doing these kind of problems. And you better simplify. Now I haven't been reminding you enough, but if you can simplify, do so. So let's divide by 2. So 62 divided by 2 is 31. 10 divided by 2 is 5. And there you have it, 31 fifths. That's the answer. Now I bet I can read your mind right now, and you're thinking, well, how come I had to do it that way? What if I wanted to just reduce that? So we should just reduce 6 and 2 tenths. Now when you reduce, don't touch the whole number. Don't touch it. Just ignore it, okay? I really shouldn't erase it, but you don't reduce the whole number. If you reduce the whole number becomes smaller, and it changes what you're talking about. It changes the meaning of that number. So we're going to reduce the fraction. So we can reduce 2 by 2 and 10 by 2, and we get 6 and 1/5. Now if we go through the whole motion here of changing that into an improper fraction, 5 times 6 is 30. 30 plus 1 is 31. And we get the same result, 31 fifths. We still end up with the same thing. Now, whatever you decide is easier is up to you. But you don't have to follow any general rule here. You can reduce that first and then change it to improper, or change it to improper first, 62 tenths, and then reduce it. It doesn't matter as long as you do your simplifying the right way. Okay? But like I said, don't reduce the whole number. Leave it alone. Do not touch it. It's a big mistake a lot of math students make, which is they reduce everything. They reduce this number, and they're not supposed to. So leave it alone. Here's another one. This one is 8 and 5/15, and this is perfect for reducing before you actually multiply. So 8 and 5/15 is really 8 and 1/3. Now I would rather do this multiplication, okay? If I were a 6th grade student, I'd rather do 3 times 8. That's not too difficult. 3 times 8 is 24. And then 24 plus 1 is 25. So 25 thirds. Okay. So 25 thirds is the answer. If you want to just do it the way it is and not reduce it until the very end, go ahead. You still get the same thing. So 15 times 8, we've established in the previous problem, is 120. 120 plus 5 is 125. Okay, now these are bigger numbers and you have to reduce them. It might not be as easy to reduce, but it's not impossible really. So divide by 5. 125 divided by 5 is 25. 15 divided by 5 is 3. So you still end up the same way. So you can kind of see a theme here going where we're not getting a different answer, no matter how you do it. Whether you reduce first or you reduce last, as long as you reduce, you get the right answer. That's all that matters. Okay, moving right along. Here's another one. Let's reduce this one. 9 and 3/4. 4 times 9 is 36. 36 plus 3 is 39. So 39 fourths. There you go. 39 fourths. Not 39 eighths. We don't have that 8 there anymore. It became 3/4 through reducing. Here's another one. This is 5 times 12. 5 times 12 is 60. 60 plus 3 is 63 fifths. All right, now let's go into how to convert from an improper to a mixed number. Now, converting from improper to mixed is basically we're doing the opposite of what we just did. Instead of multiplying, we're going to do some dividing. And instead of adding, we're going to do some subtracting, because that's how division is done. You eventually have to subtract to find a remainder. So the first step is to divide the numerator, the top number, by the denominator, the bottom number. Do not use a calculator. Now, if you use a calculator, your screen's going to pop out a decimal, and decimals are not the same thing as remainders at all, unless you're dividing by 10. And let's just forget about that. Just don't use a calculator. Use the regular pencil, paper method, and do the division the old-fashioned way, okay, with your head. And so we're going to do 19 divided by 4. Top divided by bottom. Okay, don't tell another math teacher I said that, but 19 divided by 4. Top divided by bottom. Numerator divided by denominator. The answer will be a mixed number. The whole number is the quotient, and the remainder becomes part of the fraction. So right now what I'm going to do is I'm going to go through this and start doing some of the math. So what I'm going to do now is I'm going to go through this, and I'm going to start doing some of the arithmetic. 4 divides into 19 4 times. There's my whole number. Now multiply. 4 times 4 is 16. So I'm going to put minus 16 here. And 3 is what's left over. Now there's no other numbers to bring down. Now I'm going to leave a mixed number as our remainder. Now the mixed number is made by taking the remainder and putting in the numerator. And the divisor just kind of goes back to where it was. So the 3 is right here, and the 4 is right there. So this equals 4 and 3/4. That's how that's done. Now before you move on, make sure you guys write all these steps down. It's kind of wordy, I know, but write all those steps down. Get the steps into your head, how to do it. I think this is probably the toughest thing that people have to do when dealing with improper or mixed numbers. Here's another example, 28 fifths. Now 28 goes inside, that's your dividend. 5 goes outside, that's your divisor. And we're just going to do some arithmetic. 5 divides into 28 5 times. 5 times 5 is 25. Subtract, you get 3. And now we need to leave a fraction. 5 and what? Our remainder was 3, so that goes on top. 5 is our divisor, right there. So that is that. There you have it, 5 and 3/5. Here's another one, 45/12. So what goes in the dividend part? The 45. 12 goes here. Divide by 12. 12 divides into 45 3 times. 3 times 12 is 36. 45 minus 36 is 9. And 9 is your remainder. 12 is your denominator. Now, is there anything you notice about this answer that we can possibly change? If you are saying that you can change this or reduce that, then you are correct. 3 and 9/12 reduces by what factor? That is correct. Divide by 3. Just the fraction part. Don't change the whole number. It's going to be 3 and 3/4. There you go. Where did we get the 3/4 from? 9 divided by 3 is 3. 12 divided by 3 is 4. Go ahead and do 51/17. Now 51/17, you do 51 divided by 17. 17 goes into 51 3 times. And check this out. 3 times 17 is 51. So how do you handle this? Should we write 3 and 0/17? Is that okay? I guess we could put that, but you don't really need to. Okay, if your remainder is 0, that means it worked out perfectly. It's a whole number. So instead of writing extra information, just write 3. The answer is 3. That's it. That is your answer. So if your mom said, "Hey, could you go get some milk from the store? I just want you to get 1 gallon." Would she say, "Well, can you go get 1 and 0.27 gallons of milk?" No. Your mom or dad would just say, get me 1 gallon. That's all you would do. Okay, that concludes our lesson today. Make sure you guys write a summary, write about what you just learned, go back, fill out your notes. You guys should have plenty of notes to fill up your page. You probably have over a page of notes. Fill all that out. I'll see you tomorrow and have a great night.